All right, so our learning goal today is to be able to use the skills that we've already learned with solving equations to be able to solve equations if there's fractions. So everything that we've learned so far is going to be the same. The whole idea of balance, all of those things is going to be the same. However, because of a fraction, we'll have an extra step or two. All right, now here is a warm-up to sort of remind you about exponent rules and a few other little things. So let's start off by looking at this here. So we have negative 2x cubed y all cubed. So that 3 impacts everything. So negative 2 when I cube it is negative 8. X cubed is going to become x to the 9 because we have power of a power here. And that y, because I'm cubing it, now I have 3. Our denominator, I have negative 4 and I'm squaring it. So because it's inside the bracket, the negative is included. And negative 4 multiplied by negative 4 is positive 4. I'm going to have x squared and y squared. So that's one step. Well, actually, I guess two steps if you want to think of it that way. Now I can simplify from the numerator to the denominator. Negative 8 over 16 is going to reduce to give me negative 1 over 2. Now that I'm dividing, I'm going to subtract my exponents. So I'm going to get x to the power 7. And then 3 take away 2 is 1. So when this is simplified, I have negative 1/2 x to the 7y. All right. And as a review from yesterday, in this example, we need to first get rid of the brackets. So I'm going to have negative 3x, we're going to multiply here. And then negative 3 multiplied by negative 1 is going to be plus 3 equals negative 8x minus 12. I want that 8x over on the left side, so the opposite of subtracting 8x is adding. So I get 5x plus 3 equals negative 12. Now I'm going to subtract 3 from both sides to isolate that 5x part. So 5x equals negative 15. And then one last step, I'm going to divide both sides by 5. So x equals negative 3. So that's just a little review from yesterday, or from the solving multi-step equations. So now we're going to go and look at fractions. I want you to think, what do we need to solve equations with fractions? Well, if we're just simplifying a fraction expression, when we're adding or subtracting, we need a common denominator. So I'll just use CD for that. My next question is, what is the opposite of dividing? The answer is multiplying. And then how can I make x over 5 equals 10 becomes x equals 50? We're multiplying both sides by 5. And the reason why we're doing that is because 5 divided by 5 leaves us with a value of 1. So x is equal to 50. So we're going to put all those things together, the whole idea of a common denominator. Okay, so in this example, there are several ways of doing this question. The way that I'm going to work through it right now is probably the longest way there is, but it's going to explain what's happening in each and every step, and it's going to work all the time. There are definitely shortcuts that we can use, and if you figure those out and you want to make sure that you're doing the right thing, feel free to come and ask me. A little bit later on in the lesson, I will do some a little bit quicker, but for now I'm going to sort of keep going back to those same rules. Anytime we're solving and we see a bracket, let's go ahead and get rid of that bracket. Remember, the denominator underneath each of these things, if they're nothing, is a 1. So if I multiply 8 by 1/3, we're going to get 8 over 3 plus x over 3. Because that 1/3 distributes to both of our terms. Now our life would be very, very easy if this 6 had a 3 over here. So if you think about it, I can make it have a 3. I'm going to multiply the numerator and the denominator by 3. So I'm going to get 18 over 3 equals 8 over 3 plus x over 3. Every single one of those terms has 3 as a denominator. I don't want that 3 to be there. So to get rid of the 3, what is the opposite of dividing? You already told me, multiplying. So I'm going to multiply everything by 3. 3. I'm going to write it on the side here because there's a little bit more room. And 3. The 3 becomes 1 when we do the division. It's often said it's canceling out, but technically it's a value of 1. So we have 18 equals, again, this 3 goes away, we're left with 8. And again, this 3 is going to go away, and we're going to be left with x. Now we're right back to that first day when we were doing simple equations. So to get x by itself, I'm going to subtract 8 from both sides. 18 take away 8 is 10 equals x. Now I'm going to check my answer. So I have 6 equals 1 over 3, 8 plus 10. So 6 equals 1 over 3 times 18. So 6 equals 6. Good. So I got the right answer. So what I did in that example was I got a common denominator. Some of you are probably wondering, well, miss, oops, excuse that white writing there. Couldn't I just multiply both sides by 3? The answer to that is yes, you could. However, if you do that, don't bring that 3 inside the bracket. So that's why I'm sort of teaching it this way, so you can see that it's all based on the idea of a common denominator. All right, so let's do another one. All right, so here's our example. I'm just going to check something. Okay, so there's an extra slide in here. I'm just going to delete that. All right, so now in this example, so it looks very similar to what we've been doing. However, we have a 4 on this side, okay, and a 7 on this side. Now in this example, because this 4 is all on its own and we have a single term on each side, I can multiply both sides by 4 easily. So I have a 4 here, and I have a 4 here. These 4's go away, so I'm left with 3y minus 15 equals 28. So you're probably wondering, well, where's the 15 coming from? The 15 is coming from 3y and then 3 multiplied by negative 15. So now that I've gotten rid of that denominator, and that's always going to be our goal here, because with that denominator we can then simplify a little bit easier, we're back to solving that simple equation. So now the opposite of subtracting 15 is adding 15. So I'm going to get 3y equals 28 take away 15 is going to be 13. And then finally, your final answer is going to be y equals 13 over 3. I didn't show the division in this case of both sides. If you don't want to show it, you don't have to. If you want to, put it in there. It doesn't matter. I'm going to leave the answer as 13 over 3. I'm not going to change it to a decimal. I'm not going to make it a mixed fraction. I'm going to leave it as an improper fraction, 13 over 3. Now, we could have used the whole idea of the common denominator as well. And then on this side right here, we just would have ended up with 28 over 4, okay, which gives you the same exact answer. All right, so hopefully it's starting to make a little bit of sense now. All right, next example. So here, again, we have a single term on each side. Even though the numerator has stuff going on, we have a single term. But what's different here is 3 and 5 are not the same denominator. So just like everything else, we want to get a common denominator. So our common denominator between 3 and 5 is going to be 15. So to make this become 15, I need to multiply by 5. Now this thing it's like there's a bracket around it. So I'm going to multiply that by 5 as well. The right side, I'm going to multiply by 3. Now I'm writing the 3 in front of the bracket. If you write it on the back of the bracket right here, it works the same way, except you got to remember that everything inside that bracket is going to be multiplied by 3. Now that I've done that, I'm going to have 5k plus 10 over 15 equals 3k minus 12 over 15. So mathematically, I haven't changed anything. The equation looks different, but I technically haven't changed anything. Now that I have these 15s here, I'm multiplying both sides by 15. Because then that gets rid of my denominator, and I'm left with 5k plus 10 equals 3k minus 12. And now we're back to solving a multi-step equation. We want to get k's on both sides, or the k's that are on both sides on the same side. So I'm going to subtract 3k because that's the opposite of adding 3k. And now some of you have asked, well, Miss, can I do the 10 and the 2 at the same time? You can if you want to. I'm not going to show that here because it can be a little bit confusing for students who are following step by step. However, on the side, I'll write what that would look like in a second. So then now I'm going to subtract 10. So we get 2k equals negative 12. And then one last step. When I divide both sides by 2, k is going to be negative 6. In this step right here, if you wanted to write 5k minus 3k equals negative 2 minus 10, mathematically it means the same thing. It just really depends on your comfort level. All right, so again, we're not doing anything new. You just need to be really careful with your addition, subtraction, your integers. Just like everything else with the polynomials, everything we've done so far, you need to be very careful with your integers. All right, I think I have another example. Okay, so I have 2 more examples. All right, so this one right here, getting a little bit more complicated. So same thing, I'm going to multiply into that bracket. I'm going to get rid of it. So I'm going to get 2x over 3 minus 5 over 3 equals 3 over 4x minus 6 over 4. So now I have no brackets, but I don't have a common denominator. So the common denominator in this case is going to be 12. So to get 12, I'm multiplying the left side by 4. So I'm going to have 8x over 4, not 4, sorry. That denominator is going to be 12, because I said times 4 times 4. I'm going to do the same thing right here. I'm going to have minus 20 over 12 equals, just going to change color because over here I'm going to have times 3. So I'm going to have 9x over 12 minus 18 over 12. Now that all those denominators are the same, I am left with 8x minus 20 equals 9x minus 18, because I multiplied every single term by 12. That's why I wanted that number, so that these denominators would all cancel out. So then now we're back. I'm going to subtract 8x from both sides this time because 9 is bigger and I can avoid having to have a negative. So I'm going to have minus 20 equals x minus 18. And then I have one last step. I'm going to add 18. So negative 2 is my answer. So lots of steps, lots of steps. Now, like I said, there are places where you can skip steps. I'm just showing full-on process. So first I got rid of the brackets, then I got a common denominator, then I got rid of that common denominator, and then moved terms left to right. Now, if you're watching this and you can't see, you can definitely pause it and move back. All right, so one more, I believe I said after this. All right, yes, so this is the last one. So I have 2x over 3 minus 1 over 4 equals negative 3x over 6. So common denominator again is 12, purely coincidence. So I'm going to multiply by 12. I'm actually going to do a quicker way of showing this. So instead of getting the common denominators and changing everything that way, I'm going to multiply everything by 12. So I'm going to multiply this by 12. I'm going to multiply this by 12. And I'm going to multiply this by 12. Because when I do that, 12 divided by 3 leaves me with 4. So I'm going to have 4 times 2x. 12 divided by 4 leaves me with 3. So I'm going to have minus 3 equals 12 divided by 6 leaves me with 2. So then I have negative 6x. So 8x minus 3 equals minus 6x. In this case, it doesn't make any sense to bring that 6x that's all by itself, that negative 6x, over to the left side because we want to get all of our x's together. So I'm going to bring the 8x to the other side. And then that's going to leave me with negative 3 equals negative 14x. I don't want negative 14x's. I'm going to divide both sides by negative 14. I'm not writing that x on the bottom. I'm just dividing by the coefficient that's out in front. So negative 14. So just because I want everything to be on the same screen, I'm just going to scooch over here. So 3 over 14 equals x. So all I did was change the negative divided by negative into a positive. 3 over 14 can't be simplified anymore. So this is what I would call the fastest way of doing this question. If you work through it and get the common denominator, like I showed you in the other example, you come to the exact same answer. It just includes an extra step or two, which is totally fine if that's how you need to do it. So hopefully this makes sense and you can look back and you can watch the video. And if you have any questions, you know where to find me.